everyone, it's me 𝗩𝗂 from How to Electronics. Today, I am going to show you how I designed an IoT-based particulate matter and air quality monitoring device. This device can measure particulate matter concentration in the air along with the index of air quality, volatile organic compounds, and carbon dioxide concentration. I use PMS7003 PM sensor that can easily measure PM1.0, PM2.5, and PM10 numbers in air. Similarly, I use the BME680 environmental sensor to measure temperature, pressure, IAQ, VOC, and CO2 values. I use these sensors to interface with the ESP32. All the air quality parameters are displayed on this tiny 0.96-inch OLED display. We have also a beautifully designed web dashboard. The dashboard page displays the complete air quality data in a clean and professional layout. The main dashboard shows the IAQ value in a circular gauge, which changes color according to the air quality level. Apart from these, we can observe past history and graphs for the change in particulate matter concentration values. The history and data logger page is used to record sensor readings. The data logger can be started or stopped from the dashboard, and the log data can also be exported as an Excel file for later analysis. The alerts and settings page show air quality warnings based on the sensor readings. This project is so cool and excellent for monitoring your indoor air quality or outdoor air quality. So, let's find out how we can build this device. Let's get started. The PCB used in this project is sponsored by Avon, a global leader in PCB manufacturing and assembly. Avon provides high-quality PCBs with fast production and delivery times. For new users, there is currently a special campaign that includes free shipping and generous discounts, making PCB prototyping far more affordable. You can get a PCB at $1 and PCBA service as low as $35 only and with free shipping. Let's take a look at the components required to build this project. First, we need an ESP32 microcontroller board. Then, a PMS7003 particulate matter measuring sensor, BME680 environmental sensor, a 0.96-inch OLED display, some capacitors of 10 microfarads and 100 nanofarads. You can buy all of these components easily from anywhere. Let's have an overview of the PMS7003 first. The PMS7003 is a digital particulate matter sensor using to measure dust particles present in the air. This sensor works on the principle of laser scattering. A small fan pulls air into the sensor, and a laser detects the particles passing through the air chamber. Based on the detected particles, the sensor calculates the particle concentration and sends the data through UART serial communication. The BME680 is an environmental sensor that can measure temperature, humidity, pressure, and gas resistance. This sensor includes a gas sensor that can detect the presence of different volatile organic compounds, also known as VOCs. Here is the circuit diagram for this project. The ESP32 is the main controller of the system. It reads air quality data from the PMS7003 sensor and reads environmental data from the BME280 sensor. The OLED display is used to show the sensor readings locally. Capacitors are also added near the power supply lines for stable operation. After designing the schematic, I converted it into a compact PCB layout. All the components are placed on the front side for easier assembly. Here is the 2D view of the board from the front side and also from the back side. Similarly, here is the 3D view of the board. So the next step is to order the PCB. The Gerber files were generated and uploaded to Avon. Uploading the Gerber file is simple. You just select the board parameters like material, thickness, solder mask color, and quantity. And here, you can see the total quote of just $1, and shipping is also free. If you want to order a PCB for just $1, check the first link in the description. I placed the order, and within a few days, I received these high-quality PCBs. The finish, silkscreen, and through-hole plating were excellent. Next, I soldered all of the components for 15 minutes. The assembly was smooth, and the board looks professional once completed. For ESP32, BME680, and OLED display, I am using a female header. I could insert all of the components easily here. For PMS7003, I used jumper wires as this sensor needed to be placed in a particular position. To test the entire board, I plugged in a USB-C cable and the red LED turned on and the ESP32 turned on, showing everything is good. Now, let's move on to the coding part. We will develop a C++ code to interface BME680, PMS7003, and OLED display with an ESP32 and visualize the air quality data on a web page. The code starts by including the required libraries for the project. The Wi-Fi and web server libraries are used to connect the ESP32 to a Wi-Fi network and create a local web dashboard. The BSEC library is used with the BME680 sensor to get final air quality values such as IAQ, CO2 equivalent, and VOC equivalent. The Adafruit GFX and Adafruit SSD1306 libraries are used to control the OLED display. In the Wi-Fi section, the SSID and password are added so that the ESP32 can connect to the local network. The main loop continuously reads data from the PMS7003 and BME680 sensors. These readings are then displayed on the OLED screen, printed on the serial monitor, and sent to the web dashboard as JSON data through the API readings route. Here is the header file for the project. The webpage.h file contains all of the HTML, CSS, and JavaScript code used to create the live web view. Once the hardware assembly is complete, it's time to upload the code. To upload the code, in the Arduino IDE, go to Tools, Board, and select ESP32 Dev Module. Then choose the correct COM port. Finally, click the Upload button. The code will be uploaded to the ESP32 board. After uploading the code to the ESP32, the device starts initializing all of the connected modules. The OLED display shows the sensor readings on two different pages. On the first page, it displays the PMS7003 particulate matter readings, including PM1.0, PM2.5, and PM10 values. On the second page, it displays the BME680 readings such as temperature, humidity, IAQ, CO2 equivalent, and VOC equivalent. The display automatically switches between the two pages every few seconds. If the BME680 sensor is still calibrating, a small CAL message appears on the OLED display. Once the sensor calibration improves, the readings become more stable and accurate. To open the IoT dashboard, connect your mobile phone or computer to the same Wi-Fi network and enter the ESP32 IP address in the browser. The dashboard page displays the complete air quality data in a clean and professional layout. The main dashboard shows the IAQ value in a circular gauge, which changes color according to the air quality level. It also displays live values of PM1.0, PM2.5, PM10, temperature, humidity, CO2 equivalent, and VOC equivalent. At the bottom, it shows the device status, PMS7003 status, BME680 calibration level, and lastly, update time. The PM readings page is used to monitor particulate matter data from the PMS7003 sensor. It shows separate cards for PM1.0, PM2.5, and PM10. Below these cards, a live graph displays the trend of particulate matter values over time. The environment page shows the BME680 sensor values. It shows temperature, humidity, and IAQ in large cards. Below that, it shows a comfort percentage gauge along with CO2 equivalent, VOC equivalent, calibration status, and uptime. The history and data logger page is used to record sensor readings. It logs time, PM values, temperature, humidity, IAQ, CO2, VOC, and accuracy level. The data logger can be started or stopped from the dashboard, and the log data can also be exported as an Excel file for later analysis. The Alerts and Settings page shows air quality warnings based on the sensor readings. It can display alerts for high PM2.5, PM10, IAQ, CO2, VOC, temperature, and humidity levels. This page also includes threshold settings so we can change the warning and danger limits according to our requirements. That's all for the video part today. All of the detailed written guides related to this project can be found on the website article of How to Electronics. You can find the bill of materials, schematic, PCB Gerber file, source code program, and other instructions here. I hoped you liked this video. So why not drop a like and hit the subscribe button? Finally, thank you so much for watching. See you in the next video.